Hey everyone, Mr. Hauk here. In today's video, we're going to be investigating the law of cosines. Let's go ahead and get started. So we've seen over the last several lessons that we can use something called the law of sines to solve missing parts of triangles, but only when we know very specific starting information about the triangle, such as if we know two angles in a non-included side, two angles in the included side, or two sides in the non-included angle. So when given one of these criteria, we found out that we can use the law of sines to solve for the missing parts of the triangle. But not every triangle that we have is going to meet one of these three starting criteria. So when we don't have one of those three situations, we're going to turn to something called the law of cosines. And to develop the law of cosines, let's consider this triangle right here provided to us. So we have this oblique triangle, ABC. Notice the triangle ABC does not have a right angle anywhere. So what we're going to do is we're going to construct an altitude h through angle B. So here's our altitude h. Remember that an altitude creates a 90-degree angle. Also notice, and we're going to go ahead and call this point D. This is the point where the altitude meets side AC. And if we look at the distance from A to D, we're going to call that R. Okay? So what I want to do is I want to start looking at some of the angles here, and I'm going to look specifically at this 90-degree triangle, this right triangle right here that I have highlighted in this little laser color. Well, let's take the sine and the cosine of this angle A. So since this is a 90-degree triangle, the sine of angle A, we know sine is opposite over hypotenuse. Well, opposite of A is h, and the hypotenuse of this triangle is c. So sine of A equals h over c. And notice if I go ahead and solve for h by multiplying both sides by c, I get that h equals c times the sine of A. I'm going to highlight that because that's going to be important. Now let's try to find the cosine of this angle A. Well, we know the cosine is the adjacent divided by the hypotenuse. Well, adjacent to angle A is going to be the side R. Remember, we're looking at this triangle right here. And the hypotenuse, again, is going to be c because that's across from the 90-degree angle right here. And once more, in this equation, I'm going to go ahead and isolate for r. So I'm going to multiply both sides by c. And I get that r is equal to c times the cosine of angle A. Again, I'm going to highlight that because that's actually going to be pretty important here. All right, so what next? Well, let's now look at the other right triangle because we have this right triangle right here. And let's use Pythagorean's theorem with triangle CBD there. Notice that a squared, note that here in this little triangle, a is the hypotenuse, a squared equals this leg, h squared, plus this leg. And if we think about it, if this whole length is b and this length is r, then this length is b minus r. So using Pythagorean's theorem, a squared is equal to h squared plus b minus r squared. Okay, well, let's do some substitution. This is where we're going to use some algebra. We know that h is equal to c times the sine of a. We know r is equal to c times the cosine of a. So plugging in those values, now we have a squared equals c times the sine of a squared plus b minus c times the cosine of a squared. Well, now we're going to need to do a little bit of algebra here, especially on this part right here. B minus c times the cosine of a, all to the second power. All right, so here I did some side work to calculate that. B minus c times the cosine of a squared. Let's go ahead and expand it. B minus c times the cosine of a times b minus c times the cosine of a. I went ahead and FOILed, so b times b is b squared. B times the negative c, or b times negative c cosine of a, is negative bc times the cosine of a. Negative c cosine of a times b, negative bc cosine of a. And then lastly, negative c cosine of a times negative c cosine of a is positive, because it's a negative times a negative, positive c squared cosine squared of a. Cosine squared of a, by the way, that's just cosine of a squared. That's just how we write it. Okay. Well, let's go ahead and combine like terms. B squared does not have a like term. Negative bc cosine of a and negative bc cosine of a. Well, we combine those like terms because they both have a cosine of a, and that's negative 2bc because there's 2 BC's there, negative 2 BC cosine of A, plus C squared cosine squared of A. So this chunk right here, this B minus C cosine of A squared, is going to get replaced with this term. Okay. Next thing we want to do is we want to go ahead and rearrange this equation so that we can go ahead and factor out a common piece. Notice that there's a C squared here and a C squared in this term. I'm going to collect it so that C squared sine squared of A and C squared cosine squared of A are right next to each other. And that's going to allow me to factor out the C squared. So A squared equals C squared, factored out the C squared. And when you factor it out, you get sine squared of A plus cosine squared of A, and then plus this little piece right here. Now we're going to do something pretty cool next. Sine squared of A plus cosine squared of A is actually equal to 1. And let's see why. I'm going to show you this here on this last page. So I wrote a quick little proof. It's one of the easier proofs that you'll see. But in a right triangle, sine squared of an angle plus cosine squared of an angle equals 1. And the reason this works is because, let's take a generic right triangle right here. Well, if this is the angle theta and C is the hypotenuse because it's across from the 90-degree angle, then sine of the angle theta is going to be opposite over hypotenuse, so A over C. Cosine of this angle theta is going to be adjacent over hypotenuse, so B over C. And if we do sine squared of the angle plus cosine squared of the angle, well, sine squared, we know sine is A over C, so that's going to be A squared over C squared. Cosine squared, well, we know cosine is B over C, so it's going to be squared over C squared. But notice they both have a denominator of C squared. So if we add these two fractions together, we get A squared plus B squared over C squared. But using Pythagorean's theorem, we know A squared plus B squared equals C squared in a right triangle. So this turns into C squared over C squared, which equals 1. So that's the end of our proof. So when you have a right triangle, sine squared of the angle plus cosine squared of the angle equals 1. Really cool result. So we get down to this point here. Now that we know sine squared of an angle plus cosine squared of an angle equals 1, go ahead and replace this chunk with 1. And now we have A squared equals C squared times 1, which is just C squared, plus B squared minus 2BC cosine of A. Just rearranging it to get things in a nice alphabetical order. I'm going to put the B squared first, then the C squared. So we get A squared equals B squared plus C squared minus 2BC times the cosine of A. And this is what we call the law of cosines. Now, this turns out to be only one of 3 statements for the law of cosines. There's 2 other statements. And that all depends on where you drop your altitude. Notice in this example, we dropped our altitude from angle B. If we would reimagine the triangle and maybe drop our altitude from angle C, or if we drop the altitude from angle A, we would get different results. But here's the law of cosines in its entirety. So these are the 3 statements that make up the law of cosines. A squared equals B squared plus C squared minus 2BC cosine of A. B squared equals A squared plus C squared minus 2AC times cosine of B. And C squared equals A squared plus B squared minus 2AB cosine of C. So these 3 statements together, that's the law of cosines. Now, one thing that I want you to notice is that each of these 3 statements of the law of cosines, they have the same pattern. So don't memorize the equations, just memorize the pattern. Notice it's saying, A, B, and C, these are all sides of the triangle. A, B, and C. And this uppercase letter here is the angle. So notice it says side A squared is equal to side B squared plus C squared minus 2BC times the cosine of A. So in this statement, notice that the side that is isolated over here, A, is the same angle that shows up right here. These pieces right here, so you have B squared and C squared, these are the other 2 sides. So the other 2 sides that are not isolated, those are also the same 2 sides side pieces that show up right here. And that pattern follows all the way through in the other two equations. Again, here's the side that's isolated, B, and you see that B is the angle. A and C, we see A and C here. Even in this version, this side is by itself on the left, that's the angle right here. Other two sides, A and B, those are getting multiplied right there. So if you can just remember the pattern, then you don't need to memorize the equations, just know the pattern and the equation will follow. But basically, let's talk about when we can use the law of cosines, and then we'll look at a couple of examples. So when we can't use the law of sines, we're going to turn to the law of cosines. The law of cosines can be used when we know all three sides of a triangle, or when we have side, side, side. The law of cosines can also be used when we have two sides and the included angle. It's very important that it's the included angle, so that's side angle side. Now, one thing that you want to be a little bit careful with, when you're presented with a scenario, when you're given all three sides of the triangle, you want to make sure to solve for the largest angle first. And the largest angle is the angle that's across from the largest side. The reason you want to solve for the largest angle first is because if you don't, you might actually run into an ambiguous case, and we don't want to run into that. So just make sure that you, again, solve for the largest angle first. Okay? Before we try some problems, though, let's look at a really cool example, or a really cool thing to notice. Right here it says, what happens when the law of cosines, what happens with the law of cosines when the triangle is a right triangle? So let's take this little piece right here. If this was a right triangle, then the angle, let's say the angle C was 90 degrees because it's a right triangle. Well, the cosine of 90 degrees, if you look at your unit circle, the cosine of 90 degrees is actually 0. So if this was 0, and 0 times 2ab, well, 0 times anything is just 0, then notice what you have left over is Pythagorean's theorem. So Pythagorean's theorem is really just a generalization of the law of cosines. So let's write that down real quick. What happens with the law of cosines when the triangle is a right triangle? We get Pythagorean's theorem. Really cool. All right, so let's try some examples here. In the first example, or really in both examples, we want to take the information given and we want to solve the entire triangle. So in this first example, we're given a triangle and we're given all three sides. We can see that side B is 25, side A is 21, and side C is 8. So we have a side, side, side triangle. And using this little warning in red, when solving a triangle given the three sides, solve for the largest angle first, and the largest angle is across from the largest side. So we got to solve for the largest angle first. Well, we can see that the largest side is 25, so that means the largest angle must be angle B. So that's the first thing I'm going to do, is I'm going to solve for angle B. So what that actually means for me is that I need to pick out the equation, I need to pick out the law of cosines equation that has angle B, because that's what I'm trying to solve for. So I'm going to be using this equation from the law of cosines. So you can see that right here. B squared equals A squared plus C squared minus 2AC times the cosine of B. Let's start plugging in some pieces here. So we plug in 25 for B, 21 for A, 8 for C. I went ahead and did this calculation here. 2 times AC, so that's 2 times 21 times 8. And that gets us 336. Now we're just going to do some simplifying. 25 squared is 625. 21 squared plus 8 squared, I did this piece all together, gives us 505. And then minus the 336 times the cosine of B. Now, again, our goal here is we're trying to find angle B here first. So I'm going to go ahead and subtract 505 from both sides. Doing that, I get 120 equals negative 336 times the cosine of B. And then I combine a couple steps here in the last step. I want to find cosine of B, so I know I'm going to not rather divide negative 336 on both sides. And I also know that since I want to find B, I have to get rid of this cosine. So after dividing the negative 336 on both sides, then I took the inverse cosine. So B, angle B, is equal to the inverse cosine of 120 degrees divided by negative 336. And if you plug that into a calculator like Desmos or a TI-84, and making sure that your calculator is set to degrees, you get that the measure of angle B is about 110.9 degrees. So now that I've solved for the largest angle first, it doesn't really matter which of the other two angles that we solve for. I believe I went ahead and solved for the next largest angle. So looking at the next largest side, it's side A. So I went ahead and solved for angle A next. So since we know that we want to solve for angle A, we're going to want to use the equation that has capital A, because that's angle A. So we end up using that first law of cosines equation. A squared equals B squared plus C squared minus 2BC times the cosine of A. And let's start plugging in some pieces here. So we know A is 21, B is 25, and C is 8. Again, I went ahead and did this little calculation right here. Negative 2 times B times C. That's negative 2 times 25 times 8. That gets us negative 400. 21 squared is 441. 25 squared plus 8 squared, 25 squared plus 8 squared, that's the 689. And then now we need to work on solving for angle A. So we know we're going to need to subtract the 689 from both sides. That's the next thing that we end up doing. We get negative 248 equals negative 400 times the cosine of A. And then again, I went ahead and did a couple steps in one. First, I divided the negative 400 on both sides. And then knowing that I need to get A by itself, I took the inverse cosine to get rid of the cosine. So angle A is the inverse cosine of negative 248 divided by negative 400. And if you throw that into the calculator, that gives you that the measure of angle A is about 51.7 degrees. So at this point, we've actually done all the hard work. We have all three sides. We now know two different angles. And since the angles of a triangle add up to 180 degrees, we know the third angle, which is angle C, is just going to be 180 degrees minus these two angles. So that's what we do last here. Measure of angle C, 180 degrees minus those two angles that we know, and we get that the measure of angle C is 17.4 degrees. And now we have used the law of cosines to fully solve the triangle. We had all three sides. Now we have all three angles. Okay. One more example. Let's go through an example that's not a side-side-side triangle. So in the second example, we have A is equal to 27, B is equal to 18, and the measure of angle C is equal to 137. First thing I'm going to do is create a triangle. Anytime I don't have an image or a picture, it's the first thing that I do. And let's see here. We have a side, angle, side. Very important that the angle given is an included angle. It's in the middle of those two sides. So we have a side angle side scenario, which is fair game for law of cosines. So let's figure out what we want to solve for first here. Me personally, I see that I have two of the sides. I'm going to go ahead and find the third missing side. So that's going to be the first thing I do, is try to find side C across from angle C. So that means I want to go up to my equations and I want to pick out this one right here. I'm looking for a side, and this equation, this third one, already has side C isolated on the left side. So that looks like the winner to me. So that's what I'm going to end up doing here. Use the equation right there, and let's start plugging in some pieces. So we're looking for C, nothing to plug in there. We know A is 27, we know B is 18. Went ahead and did the negative 2AB, so that's negative 2 times 27 times 18, that's negative 972. And we know angle C is 137 degrees, so I plug that in right there. Start doing some simplifying. 27 squared plus 18 squared, that's 1,053. And this piece right here, I'm just going to leave it alone. Notice I'm not doing any calculating yet. We don't want to do any calculations until the end of the problem so that the problem or the answers remain as accurate as possible. So at this point, there's nothing really we can do with this chunk anymore, but notice this is c squared, and I want to solve for side c. So to get rid of this power of 2, I would take the square root of both sides. So that's the next thing that I do. C is equal to the square root of 1053 minus 972 cosine of 137 degrees. Plug that into a calculator. Again, make sure your calculator is set to degrees, and you get that C is equal to 42. So now I have all three sides. And if I can find one of the two missing angles, then I can find the third missing angle very easily. So that's what I end up doing here. Second step, it looks like I chose to solve for angle A. So if I'm trying to find angle A, that means I want to pick the law of cosines equations that has angle A in it. So I chose this top equation right here. Okay, plugging in the pieces, we know A is 27, B is 18, and we just found that C is 42. Also calculating the negative 2BC, that's negative 2 times 18 times 42. That gets us the negative 1512. And it's just solving the equation from here. Simplifying, 27 squared, that's 729. 18 squared plus 42 squared, that's 2088. And we know we want to solve for A here. So let's subtract 2088 on both sides of the equation. We get negative 1,359 equals negative 1512 times the cosine of angle A. And then lastly, we know we're going to go ahead and divide negative 1512 on both sides. And to get rid of the cosine, we end up taking the inverse cosine right here. So angle A is the inverse cosine of negative 1359 over negative 1512. And that gets us that the measure of angle A is about 26 degrees. Now that we know that, the last step of the problem, very, very simple. We have measure of angle C. We now have the measure of angle A. That means the measure of angle B is just 180 degrees minus those two angles that we already know. And that's going to get us that the measure of angle B is about 17 degrees. Okay? So that's how we use the law of cosines. Again, we can use it when we know all three sides of a triangle, or we can use the law of cosines when we know two sides and the angle in the middle of those two sides.